There is an organ sitting in your chest right now, just behind your sternum. You have almost certainly never given it a single thought. Your doctor probably hasn't mentioned it since you were a child. And for decades, medical science largely agreed that after puberty, it was finished, done, irrelevant, a biological afterthought. That organ is called the thymus, and in March 2026, 2 landmark studies published in the journal Nature overturned everything we thought we knew about it, because it turns out this tiny, forgotten, butterfly-shaped gland may be one of the single most powerful predictors of how long you are going to live. And almost nobody knows it exists. To understand what the thymus actually is, and why doctors stopped paying attention to it, you need to go back to basics. The thymus is a small butterfly-shaped gland that sits just behind your breastbone. Its main job is to train something called T cells. These are the elite soldiers of your immune system, the ones that identify and destroy infections, rogue cancer cells, and other threats. In childhood, the thymus is extraordinarily active. It's constantly producing these T cells, shaping them, priming them, sending them out into your body, ready to fight. But then, puberty hits, and something strange happens. The thymus starts to shrink. It gets smaller. It produces fewer new T cells. And for decades, doctors looked at this process and concluded that the thymus was essentially finished. Its job was done, and so it was quietly left off medical school curriculums, ignored in clinical research, treated as one of the body's early retirement organs. That assumption was wrong, profoundly wrong. The story of how this discovery happened is itself remarkable. In the early months of the COVID-19 pandemic, a team of hematology and oncology researchers at Massachusetts General Hospital were stuck. Stay-at-home restrictions meant they couldn't go into their wet lab. They were used to fast-paced, hands-on experiments, and they needed a project that could keep the momentum going, but could be done entirely remotely. So one of them, Dr. Cameron Kushesh, began digging into the hospital's vast clinical databases. And the question his team settled on was deceptively simple. Is the thymus actually relevant to overall health in adults? 3 years later, a separate team, led by Hugo Ertz, director of the Artificial Intelligence in Medicine program at Mass General Brigham, had been asking almost exactly the same question, from a completely different angle, using artificial intelligence to read something that had never properly been read before. The CT scans already being taken from tens of thousands of patients every single year, hiding in plain sight. Here is what they found. The team built a deep learning AI model, one that could analyze the size, the shape, and the composition of the thymus from a standard routine Connecticut scan. Then, they scored each thymus, giving every person a thymic health score, and the results were extraordinary. The researchers analyzed more than 25,000 adults in a national lung cancer screening trial and more than 2,500 participants in the Framingham Heart Study, one of the longest-running population health studies in American history. And what they found was this. People with the highest thymic health scores had a 50% lower risk of dying prematurely from any cause, a 63% lower risk of dying from cardiovascular disease, and a 36% lower risk of developing lung cancer. Those are not small numbers. Those are some of the most striking longevity associations ever found in a single organ. But the thymus wasn't just predicting who lived longer, it was also changing how cancer was being treated. In a separate study, the same research team looked at CT scans and health outcomes from over 1,200 cancer patients receiving something called immunotherapy, a treatment that works by supercharging the body's own immune system to find and destroy cancer cells. And here is the critical link. Immunotherapy depends entirely on the strength of a patient's immune system, and the immune system depends in large part on the T cells being trained by the thymus. The study found that patients with healthier thymuses were significantly more likely to respond well to immunotherapy. Those patients showed a 37% lower risk of their cancer getting worse. In other words, the thymus wasn't just predicting how long you lived, it was predicting whether the drugs your doctor was giving you would actually work. Now here is the question that naturally follows. If the thymus is this important, can you actually do anything to keep it healthy? The honest answer, right now, is we don't fully know yet. The research is still new, but the scientists behind these studies are already asking exactly this question. They want to know whether lifestyle factors like diet, exercise, and sleep might influence thymic function, whether certain therapies, including radiation, might damage the thymus, and crucially, whether it might eventually be possible to regenerate or boost thymic function in older adults. Hugo Ertz, the lead researcher, put it clearly: our findings suggest thymic health deserves much more attention and may open new avenues for understanding how to protect the immune system as we age. What we do know is this: the thymus does not fully retire after puberty. It keeps working quietly for decades. Its quality matters enormously. And until 6 months ago, almost nobody in medicine was measuring it. The bigger picture here is about something more profound than one organ. It's about what else we might be missing. The CT scan has been one of medicine's most common diagnostic tools for decades. Millions of people have had one, and for all that time, the thymus was sitting there in every single scan, and nobody thought to look at it properly. It took a pandemic lockdown, a group of bored researchers, and an artificial intelligence model to finally see what was hiding in plain sight. The thymus has been overlooked for decades, said Ertz, and may be a missing piece in explaining why people age differently and why cancer treatments fail in some patients. This raises an uncomfortable question. If we missed this, what else are we missing? What other organs, dismissed as irrelevant, are quietly shaping how long and how well every single one of us lives? The thymus may just be the first answer. There is an organ sitting in your chest right now, quietly working, quietly training the cells that protect you from cancer and infection and disease. And for decades, medicine looked the other way. Now we know better, and the question that researchers are racing to answer is simple. Can we keep it healthy? Can we protect it? And can we use it to change the way we fight the diseases that kill the most people? The answer is coming. If you found this story as fascinating as I did, make sure to subscribe. We cover breakthroughs like this every single week. The science that changes everything you thought you knew about your own body. I'll see you in the next one.